Alright guys, this is going to be dividing complex numbers. And it's kind of a misleading term. We don't really divide them as much as we rationalize the denominator. And we've done this with radicals, so you've done this before. Alright, but we just got to remember that I is equal to the square root of negative 1. And since I is a radical, because the square root of negative 1 is a radical, we don't want to leave that in the denominator any more than we want to leave that radical sign in the denominator. So remember what we did with radicals is we multiplied by something called the conjugate. And the conjugate in this case is 1 plus 4i. Remember, it's exactly the same except the sign changes. So if the sign over on the left had been a positive, this would have been a negative. All right, now we can't do anything to the bottom unless we do the exact same thing to the top. Because somebody a long time ago, I guess, Fermat, the famous mathematician that invented algebra, don't you love that guy? Then he said that, and everything works because he said that, okay? So not like he made it up. All right, so now I'm going to multiply together. Now what's cool is on the bottom, when I FOIL, I get 1 times 1 is 1. 1 times 4i is positive 4i. 1 times negative 4i is negative 4i, and they cancel out. And they're always going to do that. So because they always do that, I can leave out the the O and the I of the FOIL and just do the first terms and the last terms. So negative 4 times 4 is negative 16. And then I've got 2 i's, so I've got I squared. And what's neat about these is they're always going to do the same thing. Like if you do a bunch of these, you'll notice that, every single time I'm going to change the sign of this, and it's always going to be negative because you're always going to have a positive and a negative. So this is always going to be a negative. This is always going to be negative 1, so you're going to change it, and you're going to end up with 1 plus 16, which is 17. And now you've gotten rid of the I in the denominator. So you've accomplished your goal. But you gotta FOIL this muck out. So 2 times 1 is 2. All right, 2 times 4i is 8i. Let's put this up this way. Okay, and then 1 times 3i is 3i. And I do that, remember how I do that? But do that just so that I can add the like terms together. It's sort of like I'm forcing myself to see the like terms. And then 4 times 3 is 12. Okay, I squared. Okay. All right. So now, I got 17 on the bottom, and on the top, okay, my imaginary part is going to be 11i. My real part is going to be 12 times I. That's supposed to be a 2. It doesn't look like a 2. There, I squared. So this becomes negative 1, so this becomes negative 12, and negative 12 plus 2 is negative 10. And that's my final answer. Now, usually, I like to leave them like that, but a lot of times in a book, you'll see it, or if you're looking at a multiple choice on a standard test, they will separate these into 2 separate things. Okay? And they'll have 2. They'll have the real part like a fraction, and then they'll have the imaginary part like a fraction over here. And then they put the I over here on the outside. For some reason or other, this pen will just stop writing. And then when it does write, it does something dumb. There we go. All right, so sometimes you'll see it written like that. That truly is the proper way to do it. I just get lazy and leave it like this. Okay, so let's look at this one. What am I going to do to get the radical, the I, out of the denominator? I'm going to multiply top and bottom by 7 minus 3i. Seven minus 3i. Okay, and I'm going to get, on the bottom, I always do the bottom first, because if it doesn't come out to be a number without an I in it, then I know I did something wrong, so why would I want to do the top and have it wrong too? So 7 times 7 is 49. sort of like a double check yourself. And then 3 times 3 negative is negative 9i squared. I don't even bother to do the outer and the inner because I know they're going to cancel out. If they don't, then I really didn't write it down right. Okay? So remember, this is going to be a negative 1. Negative 1 times negative 9 is positive 9. So it's going to end up being a 58 on the bottom. And I'm going to add the two together. That's my bottom, my denominator. Gotta use the right math terms here. Ooh, gotta use the right language. Okay? Not that any language teacher would know, right? But mathematicians would know. Alright, so 5 times 7 is 35. 5 times negative 3i is negative 15i. Negative 2 times 7 is negative 14i. Alright, sometimes I stack those on top of each other because they're like terms. Negative 2 times negative 3 is positive 6i squared. Oops. Okay. So remember we said up here that when we're doing the denominator, this is always going to be negative. This is always going to be negative, so it's always going to become positive. It doesn't work that way in the top. Because the top, depends on what the sign is when you start. So I can see that my answer is going to be a 58 on the bottom. Okay. All right, but on the top, my imaginary part's going to be negative 29i. What the heck? Do the parts you know, right, first. Okay, you might think this looks bad, but believe me, it's amazingly better than it was last year when I was doing this, because I'm writing literally with my finger on a mouse pad. All right, so 35. This is going to be negative 1 times 6 is negative 6. So 35 and negative 6 is, coincidentally, 29 again. Okay, it's just amazing that happened. It totally coincidence. Okay, now 29 times 29. I'm a little suspicious there. Isn't 29 times 29 58? Yeah. What do you know? This one actually can be simplified. Okay, it could actually be 1 minus I, because I just divide everything by 29. As long as I can divide everything, that's amazing. I think I made this problem up and it came out this way. If the something goes into all three terms, it can be simplified. So it says 29 goes into 29 once, 29 goes into 29 once, 29 goes into 58 twice. I can simplify this. All right. If it only goes into these two, can't do it. All right, 17 was a pretty safe bet because nothing goes into 17, right? It's pretty unique there. Whoops, nothing on the next page, so I guess that's the end. All right, thanks a lot, guys.